Welcome back from an impromptu coffee break. I apologize, that was a mistake on my side. I'm fighting the flu and my head is not completely screwed on properly. I think it was just my body saying I wanted a coffee. So I apologize for that. We'll shorten the lunch by 10-15 minutes because I think it's important that we get the full time slot for the next session. So welcome to the plenary session. Where we'll have a high-level panel discussion, hearing from our industry leaders, so industry vision, scaling up clean heat and power for homes and businesses. I'm very pleased with our media partnership with COGEN Europe and Power Engineering International to have Kelvin who's agreed to moderate the session. He's also the editor-in-chief of Power Engineering International. And so I'll give the floor to him to introduce himself and his panelists, and then take us through an interesting high-level session. Thank you.
Thank you, Hans. Very good morning to everyone here in the room, and a good morning or afternoon or evening to everyone who's joining us online. As Hans said, I'm Kelvin Ross. I'm Editor-in-Chief of Power Engineering International. And it's a pleasure to be here in this amazing venue, and also at an event that manages to blend chocolate and beer and micro-fuel cell CHP. This is my kind of conference already. We've got, this is the first of 3 panel discussions we'll be having today. This one is called Industry Visions, and it will be interesting to hear from all the players here who have taken part in the PACE project since its inception. Interesting, they will have gone into it with a vision. And they will have had lessons learned over the years, and that may have informed what their vision now is for the future and the direction of travel and where things could go, in fact, indeed, where they should go in terms of the no regrets decisions. So that'll be interesting. The panel after this is a technical panel, so we're not going to get too technical at all. And the panel this afternoon is a policy discussion. I can't promise we won't touch on policy in this discussion. In fact, I rather hope we will at some point, because it's a very interesting topic. So you'll hear directly from each of my panelists. We've got, in order from my left, we've got Philipp from BDR Thermea, we've got Andreas from Sunfire Fuel Cells, we've got Mar from SolydEra, we've got Alexander from Viessmann Climate Solutions, and we have Wolfram from Bosch Home Comfort Group. So they're going to spend about 5 minutes each, giving an overview of their takeaways from their participation in the project and what they think should happen next. Then we'll go into a Q&A. As moderator, I get to ask my questions first, but then we will open it up to the floor. So I'd encourage you to ask a question. If you do ask a question and it's to a specific individual, just make that clear, otherwise we'll assume it's to everybody. And that goes for you online as well. If you've got a question for an individual, just put their name in the question, otherwise I'll just throw it open to the whole panel. So let's get going. So first of all, introduce Philipp. The floor is yours.
Hello. Thank you, Kelvin. Hello to everybody, and also good morning to the audience online, in case you're not in our same time zone. So my name is Philipp Klose. I have the pleasure to represent BDR Thermea. We have been taking part in the PACE project with 2 brands. It's the Senatec brand with the DAX 0.8 and the Thermea brand with the Electa. And BDR Thermea, just as a short introduction, is a worldwide active full range supplier of heating solutions. And we have approximately 7,000 employees and a turnover of a little bit over 2 billion in the past years. And yeah, we have been active in the fuel cell heating industry, I would almost say all along. So we're starting in the 90s and participating in all the different field trial projects starting in Germany with Calux also being part of Innefield and now in PACE. And I'm really happy. I mean, we've heard it already in Hans' statement this morning. Really happy to state that at the end of PACE we can acknowledge the technology is fully ready for the market. It has fulfilled all our expectations, and I think that's a finding throughout the whole panel or industry. It's also economically viable for the end customers, and it has a very important impact in terms of our climate discussion, which we started this morning as well. So here we have the savings which the unit can immediately bring to the table. So it's not a future scenario, but the CO2 savings up to 50%. That's something which the technology, given the state of the energy supply today, will bring to the table right now or in part of our projects. So maybe one bold statement from my side, also looking at the hydrogen topic a little bit, enabling our discussion later on. It's not the technology which is fossil, it's really the energy carrier which we're using. So there's a big opportunity from our point of view in the fuel cell technology. And then maybe a second statement which we can elaborate further in our panel discussion. I kind of have the feeling that even though we have all these positive results in terms of performance, CO2 savings, economy for the end customers, I do have slightly the feeling that maybe politics has not yet fully understood the benefits fuel cell CHP can bring to the table in terms of producing heat and electricity. I mean, there's many people discussing sector coupling. It seems only very few really understand what it means. And if we look at some of the regulations today being prepared, namely energy labeling, what we're discussing right now, or looking at Germany with the Building Energy Act, which is currently under discussion in our parliament, we see that this benefit is not fully addressed or not even covered at all. And that's maybe one of the big hurdles which we are facing looking into the future, how to deploy this really interesting technology. Okay.
Thanks, Philip. I'm going to come back to you at some point to hear your definition of what sector coupling is for anyone who might be tuning in who falls into your category of not understanding what it means. But meanwhile, moving on, Andreas, over to you.
Yeah, thank you. So I'm Andreas, coming from Sunfire Fuel Cells. Sunfire Fuel Cells is a 100% subsidiary of Sunfire. As you know, Sunfire is focusing on electrolyzer, and we are a small company working purely on SFC fuel cells. And we are very happy and proud to be part of the PACE project. Thankful for all this support for the micro-CHP. And I want to complement that what you said. We are talking about the future of micro-CHP, and future is midterm, long-term vision, as you said. And I think we should really be clear that we also need solutions for the next years, for the transition phase. As long as we are going with fossil fuels, we have to focus on using that as most efficient as possible. And that's the fuel cell to going with that. And that's combined heat and power, because then we have the highest efficiency we could reach. And sometimes I have the same feeling like you, thinking about the vision and the future landscape, people forget that we need something for the next winter. We need something really practicable. I want to add a additional angle to the discussion. Of course, our fuel cells are running on natural gas, and this is of course pipeline based. But we are also running on LPG, propane, and this gives us a special view on the market, because there are a lot of application and buildings outside not connected to a pipeline, and that's not minor. And we also need solutions for them. And then we are with the logistic fuels. So we need to also provide solutions for application or buildings which are not connected to the pipeline. We can't, from my point of view, not go with hydrogen, bringing them to these sites, because then we would waste all the CO2 for transport. I think in that case it's also not a solution to run all these buildings on a pure electricity. So we're talking about the vision. We need a logistic fuel, carbon free, not only neutral, because today we can go with bio LPG. And then we are with ammonia. That's our vision, that the way to transport hydrogen as a logistic fuel could be ammonia. That's something I want to add to the discussion.
Thanks, Andreas. Ma, over to you.
Yep. Can you hear me? Is it working? Good. Mar van Sluijs is my name. I just joined SolydEra a couple of weeks ago, so it's really a pleasure to be already participating in an event like this, so I can meet many of the stakeholders. But it also means that I'm stepping in at the last end of the program. So I can't really speak that I have been part of the history of the program, but of course my colleagues have informed me a bit about it. SolydEra is an SME, Italian-based. Stack technology is the core of the company. The company decided to design, manufacture and supply these stacks and cells into the market through complete systems. And this is where the PACE program has been very supportive, because to get the stack into the market, we really needed a vehicle to penetrate that market. And the Blue Gen was the business model to go. And I think PACE has helped us in a large extent, in addition to some other subsidies, of course, which are more national based, to get out there with a micro-CHP, a 1.5 kilowatt unit, plug and play, so to say, in households as well as in small businesses, like the Blue Gen chocolates that you may have tasted during the coffee break. It's a pleasure for me to be in this exciting industry. My background is, has always been in the commercial sides of companies, but often related to, let's say, the conventional centralized power generators. So I was with companies who, engineering companies mainly, who were active in power generation, coal, fuel, gas, combined cycle, gas turbine type of power plants, in emerging markets. So most of my career I spent in Asia, and I'm just recently returning to Europe. And I felt personally attracted by joining a young company, very entrepreneurial, and in a very dynamic and exciting part of the power sector, so to say. And that is the reason why I decided to be here today, but also joining the company. I'm looking forward for an active discussion and to react on some of your questions that you may have, and to discuss with my stakeholders here. Thank you.
Thank you, Val. Alexander, over to you.
Yeah, thank you very much also for the invitation to this nice event today. It's a special moment for me, to be honest, because we worked hard to make this possible, what we did in the last 83 months, I think Hans mentioned this morning. And at the beginning we said we would like to have the most important project in Europe, with a few thousands even of fuel cells installed across the member states. And as we decided that many years ago, some of us, including me, were not really sure if we can achieve that. And to be honest, looking back, we did it. And it's one thing which I took with me over the time. If you are convinced that the technology, also the phase you have to go through it, is difficult, and the technology and the products and the solutions can contribute to our main target, and this is climate neutrality, as we have heard, everything in the future has to contribute to that target. One thing I took with me is never give up. Micro-CHP and fuel cells especially, and CHP in total, has never had an easy time. Also with regards to policy, Philipp mentioned that, we are still struggling with some policy instruments and understanding how important these technology as well are for our common targets. That's one thing, and this leads me to a big thank to all of you who supports this project, especially European Commission with the funding, but also the Clean Hydrogen Partnership, formerly known as Joint Undertaking for Hydrogen and Fuel Cells, which did a great job during that time. And without that bridge, we would never be in a phase like that one, even if it's still challenging. To be honest, we can really proud of that, what we have achieved. And this shows as well that the methods, the instruments we have in Europe can really contribute to a massive progress, even if in a very innovative and complex technology, and fuel cells are these ones. And the second point I would like to make, that before I should some words about my person, to be honest, I forgot that, that the most challenging phase of innovation is scale up. A lot of people think that research and development, first they underestimate the timeline which R&D needs. We need a few years to get this system done. Everyone who did research and development of real innovative technologies knows that 10 years is nothing to develop that. So we need to take the time also. But the most challenging phase is this scale up of technologies, and innovation means not to stop after research and development. Innovation means to make that really scalable in the market as the solutions for our customers. So some final word to my person, Alexander Dauensteiner. I'm the product line owner of Viessmann, responsible there for the gas portfolio, floor standing boilers, light commercial boilers, and self-evident the fuel cells. I am also coordinator of our hydrogen activities worldwide, and the Sherpa of Maximilian Viessmann, our CEO, in the German National Hydrogen Council, where we also had a lot of discussions, for example, if hydrogen plays a role in the heating market in the future, which we are sure it should play a role. At least we should give them a chance, because nobody of us, at least me, cannot foresight the future. Which pathways do we really need to achieve these targets, which are that important also for our next generations to come? And therefore we should, what I would always say, in a period like that we are in, with a very limited time we have. The time is the most challenging thing. We should probably fail in some of the paths towards the target, but we should never define the pathways just adding technical efficiencies, which a lot of people do, unfortunately, at the moment. They count also in the mobility sector. We have in Germany a lot of discussion that it doesn't make sense to make hydrogen in passenger cars because BEVs and electric vehicles, direct electric vehicles, are much more efficient. Yes, efficiency is important, but not the only criteria to be successful in the market. So therefore, I really urge policy also not to define future pathways towards our targets. Maybe we fail one of them on the other pathways. That's a risk. That's innovation, by the way. If you are not willing to fail, you will never achieve the target. We all, as a human, will never learn to go if we are not fall, as young children. So please really pledge on that what we have did. We can be proud of that, and I'm looking forward to the discussion today. Thank you very much.
Thanks, Alexander. I think it's really interesting. I've heard that several times now, that thing about innovation. Is the one thing you've got to be prepared to jump, to take that leap, and mustn't be afraid to fail, because even in failure, that you learn from that failure. It's in a way, it's the only way you can learn. It's the only way anyone learns anything, arguably. Okay, Wolfram, over to you.
Hello, Wolfram Faas from the Bosch Home Comfort Group. No? No, no, okay. Wolfram Faas from the Bosch Home Comfort Group. I have a degree in mechanical engineering and almost 20 years experience in developing fuel cell systems for automotive and stationary applications. The last few years I have spent my time in Enfield and Pace as project leader on behalf of the Bosch Home Comfort Group to uptake the fuel cell systems in the European market. The Bosch Home Comfort Group is one of the leading market supplier and manufacturer for energy efficient HVAC solutions. And our vision is to supply the market with energy efficient, sustainable, affordable and smart products and to support the decarbonization of the European building sector. And to support this, a key factor is electrification. And electrification is not only achievable with renewables. And therefore, we need other solutions. And for this, we need fuel cells in the future also for the decarbonization of the energy building sector, but we need also other solutions, diverse energy solutions for industrial, commercial, and residential applications as, sorry for that, heat pumps, hybrids, and small or large-scale fuel cells. To ensure a resilient and robust power grid for the future, we need fuel cells. Currently, fuel cells are still the most efficient way to produce electricity with fossil fuels, in the future biogas, and also green hydrogen. Therefore, fuel cells are crucial to make the energy transition happen. And it's very important to support furthermore this technology as the Clean Hydrogen Joint Undertaking did in the past with Enfield and Pace, and with the success stories in installing more than 3,000 units, fuel cell micro-CHP units in Europe. And I think there's nothing more to add, just we need more support. The scale up is not done until the final end. And so I'm looking forward to have a nice, exciting, varied panel discussion.
Thanks, Wolfram. Keep the microphone for a sec, because I'm going to start with you for the first question. I was just wondering, over your time with the project, Mirella said this morning how technologies have evolved. I wonder what evolution you've seen over your time with the project. Was there anything that has surprised you in that time that you couldn't have anticipated, or what was the biggest lesson learned?
Yeah, the biggest lesson learned, I think when we started Pace, the technology was already quite robust and reliable. The point, let's say, we have learned is when we have a error in the fuel cell system, we can see with the data management how it was operated, where's the failure, what we have to improve that this doesn't happen. And another point was, this is very important to set up not only the technology, also to do trainings, the sales channels, the service people, to offer this 10-year service contracts. And I think this was more important for Pace than to improve the technology, because the technology was also 5 years ago more or less robust as it is at the moment. Mm-hmm. It was more to set up the market, to prepare the market for fuel cells.
Mm-hmm. If any of the others want to come in on any other question I ask, please do. It's a free-for-all discussion.
I think, hello.
No.
Needs a second. Yeah, but it goes. So I think, of course, for all of us, what surprised us, what we didn't anticipate was the war in Ukraine and entailing the discussion on gas, because that certainly gave a hit in a negative way to the sales also for CHP and fuel cell systems. And the issue that I predominantly see in my head is that it's always put in one word, gas technologies, and we cannot continue in this sector, but we need to differentiate. Obviously, we heard it this morning as well. So we have natural gas, we have fossil gas, and this is of course where we want to move away. But the fuel cell really is, and I think that's I'm not lying saying this. It's really the technology which had the first hydrogen application in domestic use in households all along. So when we started beginning of the 2000s and end of the 90s, there was hydrogen technology already running in families' homes. And moving forward, of course, we can use the green gases, we can use biomethane, but we will also use pure and green hydrogen in the future. So it really has a benefit in this place in the energy transition. And just talking about gas and bashing on those innovative technologies at the same time, I think that was a hurdle which we didn't foresee, obviously.
Mm-hmm. And don't turn your mic off because I'm going to ask you a supplementary question. This session's called Industry Vision. So what's your vision for the industry, for the energy sector, for the sector that you're working in from your company's point of view? And also you mentioned sector coupling before. What's your vision for sector coupling? Rather than asking you for your definition of it, what's your vision of it?
I think with the Paris Agreement, it is clear that we need to fulfill our goals. We have a clear timeline. We want to limit our temperature rise to the 2-degree target. We want to be carbon neutral by 2050, Germany even 2045. So the goal is set where we need to go. And in our industry, looking at most of our mature economies in Europe, we can say roughly 30% of the energy usage and CO2 emissions is in the heating sector. So we are in the center, it's obvious, we are in the center of solving this challenge which we have in front of us. And I think from our point of view, we see mainly for columns or for important steps which need to take place. One is the acceleration of exchange of heating technology in the market. So we have the majority of still quite old boilers running in the market. So there already is a big chance to reduce primary energy usage and CO2 emissions. And looking a little ahead into the future, exchanging those boilers with hydrogen-ready devices, we would definitely prevent any lock-in effects. So that's one pillar, I believe. A second one, of course, is introduction of renewable sources, so that's biomass. It's also renewable electricity via heat pumps. So heat pumps will play a dominant role in their specific segment of application. So always, that's my belief at least, you have to come from the needs of the customer, from the needs of the house, and then you can define the technology and not vice versa. Thirdly, we would support an acceleration of the renovation wave in terms of the building stock, housing structure, make houses more efficient. So that's, of course, an important segment, saving energy. And last but not least, and that's, I think, the important part then for our discussion today, it's, of course, green gases, which we need as a supplement. And this will be a very important pillar also to make the energy transition quick, socially acceptable, and economically viable. So that's, I think, the important steps from our point of view. Yeah, I said, okay, electricity is part of it, so we are a full range supplier. Heat pumps will play a big role, and electrification. But at the same time, we're working since years not only on the fuel cell, but also on hydrogen boilers, for example. And I can elaborate on that a little later, maybe.
Andreas, you wanted to come in?
Yeah, you asked for the surprises during the project. And I can support this statement. So we were surprised by, of course, the war and the impact and also the bashing of the fossil fuels right now. I will come back to that in a minute, but also to see how difficult it is to motivate the installers to go for a technology where you need to be more educated, more skilled, versus taking the easiest way to get a margin. And that's, I think, a challenge for the whole sector to motivate installers. And really, the installers are key to come into the houses, to go for strategically or for the energy landscape scene for a better solution based on decarbonization of the whole sector versus having the shortest way towards the margin, which of course there are exceptions in the market, people moving forward in this direction, but we have also the opposite. And this was really a hurdle for us, challenging, and we didn't anticipate that at the beginning. Coming back to this bashing of the fossils, because I think that's a situation we are facing right now, but we need a solution also right now. And we shouldn't forget that heat pumps and fuel cells are not enemies to each other. They are complementing. So the fuel cell is providing electricity exactly in this season when the heat pump needs electricity and we don't have enough renewables from the sun. So in the winter time, when we have CHP, because then we could take the heat, the fuel cells will provide the power, and then we need as much as possible, even during the dark time, power for the heat pumps. So they are complementing technologies, and we shouldn't forget.
Interesting.
Agree. Yeah, I think that's a perfect hybrid or synergy between the two systems. Anyhow, I think energy mix is the way to go if you're talking about visions. Of course, with green gases or renewable fuel. And the sooner that infrastructure can be there, the better it is for the technologies that we are talking about here. That will definitely speed up because, as I mentioned now a couple of times already, the natural gas is an ugly word and is not in favor anymore. While this is still now for the fuel cells still the majority of its input. All right, let's see if this one still continues. Yes. I see a lot of instability coming on the grid with all these, let's say, new offtake with electric vehicles and heat pumps and so on. So I also see more and more businesses who really rely on electric security, so data centers, for instance. Who need really 24/7 and basic amount of electricity supplied to them, and they can't afford to have a little hiccup here or there, not to speak of rationing. So what we noticed in the market, besides this micro-CHP that was the main focus for PACE, but in the market I see a lot of demand coming from businesses, so commercial as well as industrial customers who are asking for solid oxide fuel cell capacities which are not yet available in the market, or only with 1 or 2 companies worldwide, like Bloom Energy. But for us here in Europe, that is still something that we need to work hard on to expand the capacities of our fuel cells, or our stacks in our case. And here, like Andreas said, time is of the essence, but you can't really rush it, because to develop these type of products, a lot of testing is needed. Yes, the PACE project accelerated a lot of micro-CHP fuel cells into the market, which gives, what Wolfram said, a lot of data to us. I mean, we were happy with so many units out there because continuously we receive data from these operations, and this is very, very vital input for the next generation of stacks that we develop. Continuously, this is a kind of loop of information, so very valuable, if not maybe most of the most valuable part of the program, I would say. Nevertheless, to industrialize a new generation of fuel cells and components for fuel cells takes time. And therefore, to address this demand in the market is not so easy. We try to come up with some cascaded versions. So this is the short-term solution to fulfill those, let's say, demands which are upcoming, and we collaborate with a lot of system integrators to develop the larger units for the future, which are mainly in the business atmosphere. So where electricity and heat demand is much higher than what we find in household.
Industrial transformation was the theme of Hannover Messe last week. In fact, it was industrial transformation making the difference. So, and fuel cell and hydrogen were hot topics, as you would expect.
Yeah.
So, how big a difference are the two making at the moment, and how big a gap is it from the potential difference they could make?
You mean in the industrial applications?
Yes.
Well, this was a very exciting show, I must say, in Hanover last week. It was really great to be there for a couple of days and to see the enormous interest from the visitors and the guests, also those who came to our booth. I was able to have some of these conversations with them. So there is obviously an enormous interest to produce green hydrogen, and therefore I would say at least 50% of the conversations were about electrolyzers. Electrolyzers, so those who supply electrolyzers into the market, they are in a boom, that is for sure. And there again, the demand is much higher than what is available in the market. We see that this demand for green fuel is visible in multiple industries. It was mentioned already this morning, the transport industry in particular. We see being active to develop solutions, whether it is for the production of that fuel, whether it is for the storage of that green hydrogen, or whether it is for the consumption of it. For instance, in the marine industry, we see serious interest for the hotel load of cruise ships, or what they call auxiliary power units on ships, to be fulfilled with a fuel cell as a provider, with methane as a fuel. So exciting, I would say. Actually, too much to be working on. So you really have to focus here.
Okay.
While on the other side, to complete your or the answer to your question, in the B2C market, we have seen, and I think Philipp mentioned it already, a kind of reduced interest. First of all, because natural gas and the war and so on, but also we have seen a lot of programs coming to an end, funding programs, and this was the trigger, in my view, my short-term view that I have so far on this business. But KfW program ended in December. The super bonus in Italy ended in December. PACE is ending now. So the larger programs are stopping, and that makes it for a lot of private customers, end customers in household applications or small businesses, not really attractive, financially not really attractive to invest in a fuel cell. So, and that is a little bit the pity of the program, in my respect, that it has not come to such a let's say, penetration in the market that what we all expected, that costs would come down by economy of scale. This, at least for us, has not happened substantially. To really say, okay, these type of solutions are also economical viable without subsidies.
Yeah. Wolfram, you wanted to come in?
I just want... Hello? Can you hear me? Yes, it's still complicated. So I just want to add something to what you said, Mars, for the industrial application. As far as we see, hydrogen will first be available for industrial applications, and therefore SIFCs are seen there as a bridge technology. My colleagues from the Bosch group, these are more than 500 or 600, are working for high power SIFC fuel cells with power more than 100 kilowatts and even more, and they sell the units by saying, today we support you with high efficient SOFCs operated by fossil fuels, but for the future, when hydrogen is available for the industry, you can just do a switch or just exchange some in the unit, and then you are completely green. And as long as this takes, you have, let's say, less CO2 emissions and less footprint. And this is what we see for industrialization. And another thing is, for the, let's say, residential market, we should not talk, we should talk about efficiency, but we should also talk about how can I do the systems more efficient, let's say the smart home systems more efficient. What we have learned from our customers, that they want to apply or let's say control their fuel cell units, that they can say, okay, today I leave the house in the morning, so the SOFC can go down to the lowest loading point, and then just over the day they have some profiles they want to use, and so they can also in this way to decarbonize a little bit their CO2 footprints from the houses. And this is another point what we have learned, that we have to offer, let's say, controls for the customers, that they are the master over their smart systems, energy systems, and all the, let's say, home appliances, as washing machines, dishing machines, and all that stuff.
Alexander, do you want to come in?
Yeah, I just would like to add what also the previous speaker said. I think what I have learned so far, also over the fantastic project we made, if we look on the targets, and the energy system, is a very complex system, as we all know. It's not consisting on a single unit in a home, or not consisting only of electricity. It's a very complex European system, and my impression is sometimes that at least some member states and some policies still, to be very clear, do not understand the complexity of the system. It's a tendency to simplify things. Yes, I know that, and we all know that. We do that every day. But it's a risk to simplify a system which we cannot change to an easy one. If you have targets such as climate protection, which is very urgent, I think nobody of us would doubt that. So there is a need to think still in these complexities, and to accept that this complexity also needs the acceptance of the system as a whole, which we need to be very clear. Everything as a solution who contributes to the target. And I can only underline also what Andreas said. It's not we had a lot of discussions what we do not want, yeah. Especially, to be honest, we Germans, yeah. We define at first what we not want. We do not want nuclear power plants, and independently which position you have, it's absolutely fine to be for or against it. I don't have a problem with that. But we define we do not want nuclear power plants. We do not want coal power plants. We do not want biomass in residential application in Germany, and. But we have too much and too less focus, to be honest. We have too less focus on the solutions. We are coming from a history, for example, also, I'm responsible for a fossil portfolio at Viessmann, yeah, which a lot of different products and also as a full supplier of solutions in the HVAC markets. And I just said in the last period of time, you cannot, let's say, make us responsible for the past to more than 100 years, which the heating industry based on fossils have heated up our homes successfully. And heat is not something which we can say, okay, we need heat and we need not. It's a base of our living. And this transition now, and this is the biggest fear, to be honest, I have, is that we accelerate the transition now in a way which we do two main failures in policy. The one thing is to simplify the system. I already mentioned that. We do not recognize that every single solution which contributes to a climate neutrality is necessary. By the way, also with regards to the time, because if we define solution and pathways for the moment, based, for example, on simply adding efficiencies, to be honest, we do not need science for adding technology efficiencies. This is something which every one of us can do it on our own. The more important would be to think of science on the complexity issue. That's the thing I should think they should concentrate. And the second problem we have is the speed. We hear a lot of other countries, we do miss the time, we started the transition towards climate neutrality too late. Yes, it might be true, but the starting point towards our targets is not yesterday and not. Ignore the history. It does not help for the future. We have now a starting point and we need, and this is the only thing which counts. The only thing which counts is not an ambition to reach targets. And the motivation to reach the targets is a very valid one. This is climate protection. But the only thing which counts at the end if we achieve the target, and that is depending on the pathways we do. So my, again, urge exactly what all the previous speakers said. Don't ignore the different solutions. We have to contribute with every single solution on every single gram of CO2 reduction. If this do the pathway, we should include that in our system thinking. That's the thing, policy. And the policy is defining. I'm just coming back from my last sentence from a parliamentary evening last week from E.ON in Germany, in Berlin, which also some of the speakers said we don't need hydrogen ready, for example, in the heating market, especially associations coming from the ecologic institutes, exactly. Yes, we can define that at the moment, but the problem is at the end if we define it and would be wrong. And I do not know the future. I cannot describe it. I'm not able to describe the hydrogen price in 2030 or whatever happens. We have no time to correct. Please ignore that not. We don't have time to correct because the time is the most challenging key, KPI, to address this target. So be open for the different solutions, add everything which can contribute. And it's up to the policy now, if they recognize these pathways in the German Building Act, Philipp mentioned, we have hydrogen ready now as a fulfilling option, but on the other side there's a paragraph described which makes it impossible to transfer the gas grid market, completely ignoring the process industry, by the way, which definitely needs hydrogen, even if you would ignore hydrogen in the heating sector as the building. Without hydrogen in the process industry, we definitely will fail. We heard that in the keynote speakers this morning. We definitely will fail in our climate target. So this is not really a way we should work policy. So again, don't ignore the different solutions. We have a perfect, let's say, portfolio of solutions, and we should include everything in our thinking towards the targets.
Thanks, Alexander. Philip, you've got one thing to add? And then we're going to take a question. Or several of them.
Just adding a little bit to what you guys said before, but trying also to give a little bit more positive outlook for our technology, what we are talking about today. So I think looking into the transition which lies ahead of us, it's clear it will not be for free. It will be quite costly, actually. And on the one hand side, we have done, or there have been studies, very interesting one from Guidehouse, looking at this transition phase. What could you do? And they actually compared two scenarios. One was going into this all-electric direction, only heat pumps, and a second scenario where they assessed, okay, what if we would use all our solutions which we have available? And the basic finding was that with both scenarios, we will reach, or we can reach our targets in 2050 climate neutral Europe. But the difference was that the all-electric scenario reaching the target was at the end 520 billion euros more expensive than the scenario using all available technologies. And that's mainly, of course, because you need to look for peak demand and build up your electrical grid in this direction. And so that's looking a little bit at the cost aspect of the energy transition. And then coming back to the statement, all the important funding projects are coming to an end. From my point of view, the most important difficulty which lies in that is the disruption in the market. So we saw the KfW 433 in Germany supplementing the PACE program in the past. And if such a program directed towards the end customer, if that stops very abruptly, unexpected, then of course that's a disruption in the market which leads to a hiccup, and you will have to restart explaining the benefits and also the financial side of things to the customers. But even though this happened now, looking a little bit into the future, my strong belief is competing technologies are becoming more expensive. So especially looking into the German market right now with the Building Energy Act, if the customers are obliged to use certain technologies which are prescribed by politics from the 1st of January 2024, the price level of the technologies is increasing. And especially if there is a shortage of technologies, but that's even a different story. So our fuel cell devices, the price we are working hard is decreasing. I fully agree we have not reached our targets, and we are still in a young technology, so there's a lot of opportunity in reducing the cost, and all of us are working hard on this. So cost, price of the fuel cell system will reduce, while competition, the playing field we are in, is stepping up into a different level. So I think for the fuel cell and for the end customer, generating also the electricity, and here I don't have the crystal ball that some of our politicians might have, saying electricity price will be cheap in the future. I have my question marks about this. So producing your own electricity at home has a benefit most likely as well. So I think with the support we see in the market, the fuel cell technology has a quite good opportunity to play a part in this future scenario. And then maybe as a last point, also looking at the price and cost of the energy transition, defining, and Alexander, that's touching to what you said initially, defining solutions and defining sectors where different fuels have to go into is completely the opposite of my understanding what the market should do and what efficient innovation is doing. So Andreas, you stated, and this is one of the important findings in the PACE project, combining a fuel cell with a heat pump will give the largest amount of CO2 savings as a product. So if we are defining then, for example, hybrids in a certain way, this can only be a heat pump with a condensing boiler, for example, then this is completely neglecting those findings and the opportunity which lies in the combination. And the same is true for, okay, hydrogen should only go into this and that sector, heavy transportation and industry applications. I think the natural gas grid has the opportunity to already absorb quite large amounts of hydrogen right now. 20% admixture in the natural gas is something that all our products could accept. And this is an opportunity in reducing the cost of hydrogen for the future. There's an immediate demand. We are not talking about we will make our steel production green and we will use hydrogen there. We could do it right now. We could give the investors who want to produce the green hydrogen an application which is there and thereby reducing the cost. So limiting the application, at least that's what I learned in school, is increasing the price. So I think we should go for the full range, and we should also maybe stop discussing colors at the beginning, because let's get started. Let's pick up speed. I mean, 2045 and 2050 is right around the corner.
Absolutely. Thanks, Philip. We'll go to some questions. We have got some online, but I'll give one to the floor first to kick us off, if we've got one. I can't believe you haven't got one. This has been so good, this discussion. No, okay, we'll go online first of all. This is an interesting one. Do you think this project, so they're talking about the PACE project, is a way to bring citizens and institutions closer together? And I guess sort of subtext of that question you could read into it is this a way of empowering the consumer, the end customer, who arguably these days has never felt less empowered, perhaps with rising energy prices, but is this projects like this, and I suppose going to that educational aspect that's cropped up in times, educating the consumer, a way of making them feel they can not just take back control of their own energy consumption and use, but give something back and play their part in the energy transition, which may be this abstract thing that's just at the moment going over their head.
So I fully agree, and to be honest, I'm very convinced that if we would not have designed the project as a project together with our customers, then we would never have achieved that level which we have achieved. Because at the end, we all design these projects and products and solutions for our customers. They and we all together decide whether we take this solution or other solution. So that's one real benefit, as you talked about, the common collaboration between end users, industry, manufacturers like that, and the institute joining and participating in the project. And this is, from my point of view, much more than only a design of this project. This is a crucial key to achieve our targets, because at the end, there's one thing clear: if we do not take customers in Europe with our targets, we will never achieve them. So we can design every regulation, even a hard one, but I'm very convinced this will change also the mindset of people following this very, very hard way and long way and a marathon towards the climate neutrality in 2050 or 45 even. So yes, my answer is yes. Also PACE has contributed significant in one thing, learning from customer experiences how good our products are and which problems we still had. I point out because I think we have really valid products now. And this was one of the things. And the others, to also convince people that this is really a nice option. And convincing people is always good if you supply a solution, not only make PowerPoint slides. Yeah? PowerPoint slides are nice, but don't convince people with slides. Touch upon the product, feel the product, experience the product, and this was really a crucial benefit of the PACE project from my point of view.
So, and empowering people or customer, for me at the beginning it sounded like hitting back to the utility, but that wasn't the motivation. The motivation, what I felt during all these discussions was, I can do something. And the decision was not based on, oh, I can get some funding and a contribution to, no. I did something to reduce my CO2 emissions. This was the basic motivation, and this is empowering of the customer, that they can do something towards the common goal of all of us. That was interesting.
Wolfram?
And you do not have just only this customer. You have different customers. One are early adopters because they think, oh, what an exciting heating system, powering my home, and others looking more to the CO2 prints. But we have very different customers, and so it's not that customer. We just have to see what customers we have and how can we serve them with the right system. If these are fuel cells, would be nice. Yeah, but that's we have learned from the PACE project.
Mm. We've got about 4 minutes left to still give ourselves an hour for lunch. Does anyone have a question?
20 years ago, there was an advertisement by a large German utility where you could see a boxy thing, a fuel cell in a shopping cart, and an enthusiastic girl shoving it around the aisles of Home Depot or something. No? And it lasted more than 10 years until the technology became customer-proof, I would say. No? Then, since a couple of years, you can actually order it from you guys and with a kind of guarantee and so on. And we need still bring the cost down. You talked about it, no? And there was this Ouroboros cycle, so the snake which bites in its tail. And that means if you produce only low numbers, that means high production costs, that means a higher complicated sales process because it's more difficult to explain to the customer why to use this expensive technology and so on. So what strategies are there to speed up this Ouroboros cycle? So,
Alexander?
I would like to be really short. What we do have is not to make only climate policy, but also industry policy. That's the answer of your question.
I think that's a pretty short but comprehensive answer. Was there another question? Yes. Two. Yeah. Red shirt, middle row.
So my name is Twan from Entras. So you have talked about fuel cells, micro-CHP generating heat and electricity. What I've missed so far is the energy storage that you could use, the synergies that it could have, and the opportunities for cost reduction that it could bring together with the fuel cells. Could you comment on that? What is the role of energy storage for fuel cells?
Who wants to take that one?
So I think that is one of the intrinsic benefits of a fuel cell system, that here we have a controllable and in most cases modulating device. So this can really react on the demand of the energy needs, whether it being the heating demand or the electricity demand. So of course you could supplement the fuel cell heating system with energy storage to increase your self-consumption at home. But having with the CHP device a player in our energy system that is controllable, we have the opportunity to supplement all the renewables which are fluctuating, and the CHP devices can contribute stabilizing the grid on low voltage level. So I think in itself it's a benefit to our electricity grid by this function to be controllable and modulating.
Mm.
And just one addition to that, don't forget that even due to the fact that it is a molecular-based system, coming from the gas grid itself is a storage. If you would have a product just using electricity is a transport system, gas system is a transfer system and a storage system. So this answers, in addition to that, what you announced, this is absolutely clear. Batteries and other energy storages makes absolutely sense, but the grid itself is a big storage.
Thanks, Alexander. I think we had one more question, just to be fair.
Hi again. It's working, right?
Yeah. Yep, it's working.
I have two short questions, one for Mr. Klose and one for the whole group. Mr. Klose, you were talking about hydrogen boilers. I was just wondering, I think everyone knows that hydrogen is extremely dangerous, so is also gas. How do you see in keeping, when you produce the boilers and make them in home, how can you keep them safe, even though I think everyone agrees that it is the future? How can we keep those systems safe as possible? And my second question was, we talked a bit about biogas. Do you guys see any future in the splitting, because I know it's possible, the splitting of biogas into hydrogen, or do you think there's only a future in purely green hydrogen? Thank you.
Thank you. Okay, Philip, you take your question first, and then the rest of the panel can tackle biogas.
I don't know if I would agree that hydrogen is a very dangerous gas in the first place. So hydrogen is a gas. It of course has different properties than other gases, but also methane or natural gas is dangerous if you deploy it in the wrong way. So my answer to your question would be that our hydrogen boilers we have developed. I think in 2017 on ISH we have exhibited a hydrogen boiler for the first time. In 2019 we started with the first field trial, which is still running. It's hydrogen production on site. It's in Rosenburg in the Netherlands. And building on that, we have set up our own hydrogen production in our plant in Italy, for example. We have introduced other field trials in the Netherlands, in France, Germany, UK, with hydrogen boilers. So we have close to 100 boilers right now running, hydrogen boilers. And this culminated maybe in installation in Lochem in the Netherlands end of last year, and here we have 12 monumental houses in one street. So originally when we started, some of the tests were in empty houses, but this now in Lochem is really monumental houses. So you cannot do insulation, you cannot install a heat pump. People would just be freezing in those houses, or it would be very expensive at least to heat the house. So here we are deploying hydrogen boilers in the whole street. The houses are inhabited with the normal owners or tenants, and the supply of the hydrogen is via the original pipeline network. Of course, it's being supplied via tanks, but we're using the normal grid in the street, and the boilers are running in the house. So it is a standard gas. You need to look at the specific properties in terms of your safety concept in the boiler and how you control the combustion. But this is all technology which has been developed and is safe and sound for usage.
Thanks, Philip. Who wants to take part 2 of the question?
I would answer that more from the question of storage. So also come to your question. You could either store energy in electrons or in molecules. And electrons is short term. And if you can't reach a certain application with electrons, you would convert either the electrons or taking biomass to produce molecules to have energy available for a certain application. And yes, based on the biomass, which is a good way, especially if it comes from bio-waste, then you have molecules available and you could either burn that or convert that or even convert that to methane or finally to hydrogen and then use it. And I would not stick on a certain path complementing the comments of Alexander. It's open to the situation and the application, how you could use the biomass.
Thanks, Andreas. We'll end with a final online question, because it's potentially a yes or no answer, but it's an interesting one. And that is it easy to come together as a coalition formed by many industry partners, as well as researchers? So I guess it's saying, is this spirit of collaboration that we're seeing throughout the energy sector, rather than what might have been once a spirit of competition between all 5 of you? How easy has that been? How productive has it been? And is it really the way forward for all of you from this point on?
It's a great question, and I will give the mic soon to Alexander, who is the father of this project, I would say. And I simply want to take the phrase co-opetition, cooperation and competition, and that's what we trained in this project.
Yeah, I can only underline that, first of all, there's a competition law and we have to fulfill that. And we did it. So we are very successful in that, but I agree fully what also Andreas said. Looking on what I mentioned with the question of how did we get through these challenges with industry policy combining with climate protection policy. It's the same when you're looking international policies, especially the competitors in Asia or US, yeah? For example, Inflation Reduction Act of Biden, for example, yeah, which is really a big competition also in hydrogen policy for Europe. Don't start too early with a strong competition if you are in a phase which we have still to development the markets. And therefore the PACE project was one of the most important bridges to markets in the different member states in Europe, and markets where we address the micro-CHP fuel cell solutions. And collaboration is a key. If we do not collaborate, either in industry within project or in the different other sectors and targets, I am very sure then we will fail. Collaboration is key.
Yeah, and it's not only from the technical point of view, the competition, but we as Bosch Home from Comfort Group, as we named now, sell more or less the same unit as SolydEra did. That's a deep cooperation, but we use our sales channels because we are the better entrance to the market. And therefore it was a good cooperation. We have the very efficient technology, and we helped SolydEra in a way to sell more units and perhaps to reduce the costs. And this can only be happening in such projects, I think. Otherwise we wouldn't have such a deep cooperation, and this was very successful for us and hopefully also for SolydEra.
I fully agree that collaboration and co-makership is the way to go in this market penetration phase of this technology. I also think when the tide rises, all boats float. So that, of course, we all have to find our role and position in that market as it is so dynamic, and we have discussed that from different angles. But yeah, it is definitely the way to go, so the answer is yes. Okay, great. I think we have to end it there. We've
taken up some of your lunch hour, but I think we've delivered you a feast of information, insight and opinion here. Hans, are we still coming back at 1:45? We are, so you've got a little less than an hour for lunch. I've really enjoyed this, it's been great. This has been a fantastic panel, and I'd like to just show you appreciation for them and their insights that they've shared today. Thank you.